Welcome back. In my previous video I had seen the Schwarz Lemma and identity theorem. Just recall the statement, let D be a unit disk in the complex plane and F be a mapping from D to D closure which is analytic function with the condition f of 0 equal to 0. If these two conditions be hold, then by Schwarz Lemma we can tell modulus of fz less than equal to modulus of z. By Schwarz Lemma we can tell this, and f prime 0 less than equal to 1. And if the equality hold, means if modulus of fz equal to modulus of z, this is hold for all non-zero z, and if modulus of f prime 0 equal to 1, then that implies fz equal to az with modulus of a equal to 1. If equality holds, means modulus of fz equal to modulus of z, or if f prime modulus of f prime 0 equal to 1, then we can tell fz equal to az with absolute value of a equal to 1 with this condition. That means if a function fz is such that fz is analytic on this disk, second, modulus of fz less than equal to 1, this is true for all z belongs to D. Third, if f0 equal to 0, then if f0 equal to 0, that means f has a simple 0. Then by Schwarz Lemma, 1, modulus of f prime 0 less than equal to 1, and second, modulus of fz less than equal to modulus of z, and this is true for all non-zero z. In my previous video I had seen about this part, I had proved this lemma. So at first I will highly recommend you, please see my previous video with pay attention, then you will understand today's video in better way. Today's goal of this lecture, today actually I will see extension of Schwarz Lemma and Schwarz Lemma. Then I will see some exercise based on this theorem. At first I will see one example based on identity theorem. Then I will see what is the extension of Schwarz Lemma, Schwarz Lemma. Okay? See, first example of identity theorem. First question, f which is defined from complex number to complex number which is entire function, and g which is defined also complex number to complex number be defined by gz equal to fz minus fz plus 1. This is true for all z belongs to complex number. Then which of the following statement are true? A. If f of 1 over n equal to 0, and this is true for all z belongs to z plus, then that imply fz equal to constant. B. If f of n equal to 0, and this is true for all z belongs to z plus, then fz is constant. C. If f of 1 over n equal to f of 1 over n plus 1, and this is true for all z belongs to z plus, then cz is constant. And D. If f of n equal to f of n plus 1, and this is true for all z belongs to z plus, then cz is constant. This is use of identity theorem. I hope my all viewers have understood. Here gz equal to fz minus fz plus 1, and since f is entire, so obviously this gz is entire function. And we all of us know the identity theorem. If fz is analytic in a domain D and the limit point of zeros of fz is a point of D, then we can tell fz is identically 0. That means if zeros of limit point is a point of D, then we can tell fz is identically 0. Notice first option here, f of 1 over n equal to 0. f of 1 over n equal to 0, that means the set S contain 1 half, 1/3, 1 over n, so on. This is the zeros of fz. That means this is actually the set 1 over n such that n belongs to natural number. And as n tends to infinity, 1 over n goes to 0. That means zeros of fz is limit point of zeros of fz is 0, which is belongs to the domain D. So by identity theorem we can tell fz is identically equal to 0. So option A is a right option. And option 2, if fn equal to 0. Notice here limit point n is the zeros and limit point of zeros is infinity. But here the function defined from complex number to complex number. Infinity, this limit belongs to extended complex number, does not belongs to the domain C. So by identity theorem we cannot tell fz is constant. So option B is a wrong option. And option C imply f of 1 over n equal to f of 1 over n plus 1, and this is true for all z belongs. Notice here gz defined fz minus f of z plus 1. Since here f of 1 over n equal to f of 1 over n plus 1, f of 1 over n equal to f of 1 over n plus 1. Therefore, this is equal to Cz equal to f of 1 over n minus f of 1 over n plus 1. That means this is actually not Cz, this is equal to z of 1 over n. And limit, if z of 1 over n equal to 0, that means set of zeros are 1 over n such that n belongs to natural number, and since 1 over n as n tends to infinity goes to 0 and 0 belongs to complex number, so by identity theorem we can tell z of 1 over n is identical equal to 0. That means option C is a right option. If f of 1 over n equal to f of 1 over n plus 1, then gz is constant function. And option D, f of n equal to f of n plus 1. This is g of n equal to f of n minus f of n plus 1. And this value is equal to 0 means here 0 set is n and limit point of 0 set is goes to 0. So by identity theorem we cannot tell gz is constant because limit point does not belongs to complex number. So option D is a wrong option. So only A and C is a right option. I hope my all viewers have understood this is okay. Well, now I will see what is the extension of Schwarz lemma. What's lemma? f0 equal to 0 means f has a simple 0. But extension of Schwarz lemma is if a function fz is such that fz is analytic on the domain D such that D equal to z such that modulus of z less than 1 and modulus of fz less than equal to 1 means absolute value of the function is less than equal to 1. This is true for all z belongs to D. See, fm0 equal to 0 means f has a 0 of order m at z equal to 0. Then absolute value of fm0 less than equal to m factorial, and second absolute value of fz less than equal to absolute value of z to the power m, and this is true for all z belongs to the domain D. That means Schwarz extension lemma used for when higher order 0. If it has a 0 of order m. That means by Schwarz extension theorem, this would be f to the power m0 would be less than equal to m factorial, and modulus of fz would be less than equal to modulus of z to the power m. When in Schwarz lemma 0 of order 1, then always I have got modulus of fz less than equal to modulus of z. But here, since f has 0 of order m, then that imply by Schwarz lemma modulus of fz less than equal to modulus of z to the power m. That means the corollary to Schwarz lemma, suppose fz is analytic for modulus of z less than r with the condition f0 equal to f dash 0 up to f to the power n minus 1 0 equal to 0, and if modulus of fz less than equal to m, and this is true for all modulus of z less than r, then absolute value of fz less than equal to absolute value of z to the power n over r times m with modulus of z less than r, and with equality holds, then fz equal to m over r to the power n e to the power I alpha times z to the power n, where alpha be real number. Okay. Now let's see one which had come in CSR net exam. Consider d equal to z belongs to complex number such that modulus of z less than 1 be open unit disk, and consider the mapping f from d to d which is holomorphic function, and such that f of 0 equal to 0 and f prime 0 equal to 0. Then which of the following are possible value of f of half? Option 1 1/4, option 2 minus 1/4, option 3 1/3, option 4 minus 1/3. Here d equal to z belongs to complex number such that modulus of z less than 1, and the function defined f from d to d. Since f from d to d, that means obviously that imply modulus of fz less than 1, and given f of 0 equal to f prime 0 equal to 0, and the corollary of Schwarz lemma, if fz less than equal to m, then absolute value of fz less than equal to absolute value of z over r to the power n times m. Here, since f0 equal to f prime 0 equal to 0, that means n equal to 2 and m equal to 1. If we apply this here, then these imply modulus of fz less than equal to modulus of z whole square. Therefore, just put the value, what is the possible value of f of half? F of half would be, since here I have got fz, modulus of fz less than equal to modulus of z whole square, that means f of half less than equal to absolute value of 1 over 4, 1 over 2 whole square, this is less than equal to 1 over 4. That means f of half, this is lies between 1 over 4 and minus 1 over 4. So this value would be option 1 and option 2. This is the right option. Now I will see what is the Schwarz lemma. If fz is analytic in the domain modulus of z less than 1, then Schwarz lemma tell modulus of fz less than equal to modulus of f0 plus modulus of z divided by 1 plus modulus of f0 times modulus of z. Second, modulus of f prime z less than equal to 1 minus modulus of fz whole square divided by 1 minus mod z whole square. For this, actually, when f0 given, but we have to find f of a, then we can use this lemma. Also, if f of a given, but we have to find f prime a, then you can use this lemma. Actually, This is let z d equal to z such that modulus of z less than 1 be a open unit disk in the complex plane C, and consider the function f from d to d which is holomorphic. Then for all z belongs to d, a prime z over 1 minus modulus of fz whole square. This is less than equal to 1 over 1 minus modulus of z whole square. This is the Schwarz lemma. This lemma is very important for higher study, also for all competitive exam. Next, I will see some example about Schwarz lemma. First question, let D be the subset of complex number be open unit disks, and consider the family of all holomorphic map f from D to D such that f of 0 equal to half, where f belongs to this group family of f. Then the possible value of f prime 0 are option 1 7 over 8, option 2 5 over 6, option 3 3 over 4, and option 4 equal to 1. What is the possible value of f prime 0? Apply the Schwarz lemma here. Since here we have to find the f prime 0 and given f0, therefore I will apply these rules. This modulus of f prime z less than equal to 1 minus modulus of fz whole square divided by 1 minus modulus of z whole square. Since f0 equal to half, therefore modulus of f prime 0 less than equal to 1 minus f0 whole square divided by 1 minus 0, and this value is less than equal to 1 minus half over 1. So this value would be here would be 1 over 4. So this value would be less than equal to 3 over 4. So option 3 is the right option. I hope my all viewers have understood this is clearly. Okay. Next, let d equal to modulus of z less than 1. Then there exists a holomorphic function f from d to d closure with the condition f of 0 equal to 0 with the properties. Option 1 f prime 0 equal to half, option 2 f of 1/3 equal to 1/4, option 3 f of 1/3 equal to half, and option 4 f prime 0 equal to sec pi over 6. Here also I will apply the Schwarz lemma. Modulus of f prime z less than equal to 1 minus modulus of fz whole square divided by 1 minus z whole square. This is the f prime z. So for this here I will use here f prime 0, and given f of 0 equal to 0, this is less than equal to 1 minus 0 over 1 minus 1, this is less than equal to 1. That means f prime 0 less than equal to 1 and half also less than equal to 1. So this is the right option. F prime 0 equal to sec pi over 6. This value is 2 over root 3. This is not less than 1. So this is wrong option. Here f of 1/3. For this, since f of 0 is given, so we can apply these rules. Modulus of fz less than equal to modulus of f0 plus modulus of z divided by 1 plus modulus of f0 times modulus of z. So f of 1/3 would be less than equal to f of 0 means 0, modulus of z means 1/3 divided by 1 plus f of 0 also 0 times modulus of z means 1/3. So this value would be less than equal to 1/3. So I have got modulus of f of 1/3 less than equal to 1/3. 1 over 4. 1 over 4 less than equal to 1/3. So we can tell, since I have got modulus of f of 1/3 less than equal to 1/3, and here f of 1/3 equal to 1/4. This is the right option. But in third option, f of 1/3 equal to 1/2. This is not right because 1/2 not less than equal to 1/3. So option C is a wrong option. That means option A and option B is a right option. I hope my all viewers have understood this is okay. Oh, I will stop here. In my next video, I will discuss Lorentz series. Also, I will discuss more example about Schwarz Lemma and identity theorem. Actually, these two theorems very important for any competitive exam. Okay. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.